Okay, so we used the chain rule to differentiate this function. We wrote it in exponential notation, took the derivative, and simplified it. So when you're taking the derivative of this kind of a function, you need a chain rule. That is, when you're taking the derivative of f composed of g of x, you take the derivative of f acting on g of x multiplied by the derivative of g of x. Okay, so the derivative of the outside acting on the inside times the derivative of the inside function. If we take the antiderivative of this function, we know we're going to end up right back here, x squared plus 1 to the 1/2 plus a constant. But the only reason we know that is because we just finished doing it. If we hadn't just finished doing it, how would we know how to reverse the chain rule? So we're going to use substitution. That is, if u is equal to g of x, that is, u is the inside function, then the antiderivative of f composed of g of x times g prime of x is going to be the integral of f at u du. Okay, so just have a look up here. It's like saying this. If I wanted to take the antiderivative of f composed of g of x times g prime of x, to work it backwards. Okay, so here's how the substitution works. We let u equal g of x. Okay, so I've got f composed of g of x. I'm letting u equal this inside function g of x. Then if I took the derivative with respect to x, then I would be taking the derivative of g of x with respect to x, which would give me du by dx is equal to the derivative of g of x with respect to x, g prime at x. Or if I multiply both sides by dx, I get du equals g prime of x dx. So look here at our substitutions. We let g of x equal u. And then we worked by taking the derivative of both sides with respect to x and simplifying algebraically, we get du is equal to g prime of x dx. So g prime of x dx gets replaced by du. G of x gets replaced with u. So instead of f composed of g of x, I've got f composed of u. Instead of g prime of x dx, I have du. Okay, so take a minute and look that over.